you'll probably admit is not very much.
But a lot of them are like that.
We answered the problem. And like I say, I'm happy if you bring it to here. If you want to carry it further for your own personal practice and edification to solidify and build your confidence in doing this and manipulating these, because the only reason this is so important is because when you go moving further on in chemistry and physics and all these areas, it turns out there's one function that is at the heart of everything, and it's going to be, in various guises, it's going to be e to the x, and this could be a minus, it oftentimes is, or it could be a plus x, or it can have complex things going on in it, but it's always going to come down to manipulating this type of a thing. There is a thing called a partition function. I've talked to you guys about equal partition of energy all year since freshman chemistry. The partition functions are e to the minus e over RT. That's going to be the partition function for whatever that particular form of energy is for each of the degrees of freedom. And it turns out that that's going to be the heart and soul for really addressing in the real world kinetic problems and thermodynamic problems. The partition functions are the super functions of thermodynamics. So when we go and carry thermodynamics further to its next conclusion, we're going to be living in the exponent. We make our living there. When you go on to do particle physics, if you want to do quantum electrodynamics, there are these things called generators. And the generators turn out to be e to some matrix. And operators and things like that. It's all going to come back. This is the uber thing of all time. And so you really want to be, we make our living, we live in this for what comes on from more advanced studies. So this is going to help reinforce your foundation there. Yeah?
I'm sorry, can you explain again the second line?
Which one?
The one where
This one?
silver is equal to the 2. Yeah, where does the 2 come from?
Because this was the silver chloride, the KSP. This was just KSP. You got that, right? Is equal to the silver ion concentration times the chloride ion concentration. And we just saw for the chloride ion concentration was 1/2 molar. So I just wrote it out this way. And then that means I can isolate the silver concentration is equal to 2 times KSP. I want me to break that down.
You divide it by 1/2 to each side. When you divide by 1/2, you multiply by 2. Right.
Yeah.
When you solve for the concentration of silver.
Yeah.
Pretty much ignore the middle part.
Yeah. Here, let me.
It's not very good notation, but.
That notation was a bit awkward. Let me clarify that one. So 10 to the minus 9.74 times times 2. So I'll just move it that way. Is equal to the silver ion concentration times 1/2 times 2. So I just multiply both sides times 2. And this drops out and gives me that the silver ion concentration is equal to 2 times 10 to the minus 9.74. Does that make it clear?
Yeah.
Okay. Yeah, I guess I was a little fuzzy on that. So yeah, but thank you for asking. Okay. And now, and then I just erased part of this, but what was here? Oh, 10 to the 10. Yeah. Which we can continue to play with. And the rest of it was just, I'm happy if you take it to that and you just say that molarity. I would have been pleased, as happy as a clam at high tide. But if you want to continue just for laughs, you can carry it out to this level. And whether you get it right or wrong, I'm not going to care. I'm going to give you full credit. But you're for extra insight. Feel free. practice all you want. If you make a mistake here, I may correct it, but I'm not going to deduct points. Okay? Because that's over and above. Now, over and above, I mean, trust me, the faculty in this district couldn't do this. And so I'm not going to hold you accountable for that one. I had to include a slight of the faculty in my talk. I wanted to get it on film.